So he only swam like sideways because he had like this bladder constipation thing.
Okay. Alright, I'm actually recording a stream, so I wanna see that. I forgot to use my camera. So I'm going to, the stream is kinda, sometimes, are you guys doing any video chats or like you and Dodo? Well, right now I guess you're not. But I'm looking at this frame rate and it's 15.9, 15.48. I guess that's not super bad, but okay. I'm gonna try to make sure my microphone is using my Yeti. Okay, it's using my Yeti microphone, which was not plugged in before, but now it is. Okay. Alright, I'm gonna do this coding thing. And let's see, my streaming. It says it's excellent condition, so I guess that's working. Okay. Are you gonna look for Dodo? What are you planning to do?
I don't know.
You don't know? Okay. Okay. I don't know for. I'm sorry about that. If you're watching, perhaps if you're watching this video recorded, then maybe I'll tell you to skip this part, or I don't know exactly what. But I'm actually gonna restart my task, which was to well, it started out as we wanted to do the next step work of building this deep zooming viewer for the programming state of a program as it is visual debugger. But I decided that before I do that, I want to build a framework for laying out boxes, and the name I have in mind is probably Fitbox maybe. And I also realize I misspelled layout over here, so perhaps I go ahead and fix that. Okay. Okay, so the first thing I guess I want to do is to do the basic code example for filling, like displaying text in a canvas. I'm using the HTML5 Canvas API, which I've gotten a lot of practice using over the last couple years in various side projects. So the way you render some text is using the fill text method, and so you give it a number, zero, let's say, let's do 100. Let me refresh my browser, and there is your text. I'm gonna make the text a little bit bigger. The way you do that is you set the font declaration, which is a combination of three things: the font weight, so I'm gonna say normal, a pixel size, let's do 25 pixels, and then finally a font. I'm gonna do Inconsolata. That's my favorite monospaced font, and there's my text. Okay, so now if I were to the premise of what I'm doing is I have a box and I want to fit the text inside of it. So let me and I had a concept called the bounding box. Let me write that. In TypeScript, a bounding box I'm gonna define in this way. There's a top and the left pixel coordinate. You could also call these X and Y. And then you have a width and a height. Okay. So a box might be, I'll call it BB for bounding, but B box. Okay, so a bounding box is, let's say the top is 100, left is 100, width, let's do 300, height, let's do 300. And this box would, excuse me, let me get my tablet so that I can draw for you. Not really prepared today for this video stream, but that's alright. This is very spur of the moment kind of thing anyway. Okay, so because my canvas is gonna be from, my canvas has the width and height of 500, 500, right? So this is 500, and this over here is also 500. If I did top 100, 100, that's, I think, this point here, and I draw a bounding box of width and height 300, 300, that should be approximately here. So let's go ahead and draw that box. And the way to draw that box using the Canvas API is stroke rect. It strokes a rectangle, and the top and the X and Y should be left and top. So B box left, B box top, and then the width would be, and height would just be B box width and B box height. So let's see that. Assuming that works. What is this error here? It worked. I'm not sure what it, cannot find BB. I don't have BB. Oh. My computer is slightly slow, I think. And I think sometimes it's the streaming software that's using up a lot of CPU, and maybe the TypeScript compiler is also using up a lot of CPU. I don't know, but so far the streaming quality is still okay. Maybe I'll move this guy to another tab, so in case I want to check the streaming quality, I can just switch to that tab. Okay. Alright, so now I want to render this text inside the box, and there's different modes of rendering text. If I tell the text to render at this pixel, which 100 and 100 is this top and left corner here, and I want the text to get render underneath that pixel, I can do that, but the default doesn't do that. The default sort of uses that pixel as the baseline, or as the bottom of the text. I could tell it that I actually want that to be the top of the text, and the way is to do that is to set the text baseline to top for the canvas, and then now the text goes inside the box. So I have the text inside the box now. But the idea is I actually want to sort of render this text as large as possible within this bounding box. And usually I also want to center it, but actually I'm not going to work on that part right now. Before I work on that part, I actually want to build this sort of box-based layout algorithm, where, let's say I have multiple boxes that each containing text within them. So let's say, I don't know, hello is a box, and maybe world is also a box. And each of the boxes know how high, how tall and wide it needs to be. and then we can have a parent box that sort of lays them out either horizontally or vertically. And perhaps it might be easier to show using code. I'm gonna call this guy box. This is what I called it last Friday. And even though this name collides with the word bounding box, I think I'm still gonna use them. I couldn't think of a better name last Thursday. Yeah, so I'm still gonna call it a box. Conceptually, it's kind of like a DOM element. So another name I could use for this is element, but I kind of don't want to use that because that word is really, really overloaded. So I'm going to call this box. In a box, there's two types of boxes at the moment. There's a text box and there's a container box. And a text box, each of them have a type discriminator. And this is a trick in TypeScript, which I use a lot. I have a text box that is an object that has a type discriminator, and then container box is also an object that has a different type discriminator. And then later on, we can use either an if statement or a switch statement to discriminate the type to figure out which one of these two types which kind of these two types of boxes that a particular box instance is. And I'm gonna say, maybe I'll explain more later as I write this code. A text box, I'm gonna say, is gonna have a additional text, whereas a container box is gonna have some child boxes. So I'm gonna call these guys children, and children is an array of boxes, which in turn can either be a text box or a container box. So you can imagine we could lay out text into a series of sort of containers, so either vertically or horizontally. Speaking of which, a container box can have a direction which is either vertical or horizontal, like this. Okay. And what I'm thinking is, so you can have a container like this. So this is a container box, and within the container box we could have text boxes. And each text box can have some text in it, so perhaps hello world. And in this case, we're saying the direction is vertical. We'll say this container box has vertical direction, and if it had horizontal direction, then it would go this way instead, right? Hello world. So this is a horizontal direction container box. So that's the idea, but because the children, so the hello box and the world box are the children of this container box, but the children could be container boxes in of themselves too, so which means you can have more, perhaps it can be like this. You can have any number of layerings of these things. So maybe this is a container, but the container's children are containers as well, but it's the innermost boxes that are actually text boxes. So the innermost text boxes are text boxes, and then that's the ones that actually render text and so forth. So that's also possible. And yeah, so that's the idea I'm going for. Once I have this framework, then I can implement something like the fit text function, which can automatically figure out the largest font size to use to fill up an entire bounding box. So that's the idea. And I think the first thing I want to do is, so given a box, lay it out. So I'm gonna make a layout function given a box, which has type box. It's gonna need a canvas context. Canvas rendering context 2D is gonna need that, which is what that guy is. It needs that because it needs to be able to measure the text. It's also gonna need a font size. So for a given font size, or maybe not actually. Maybe I just let the font size be whatever the current context object has, and I don't worry about that. Okay, because this is actually a stateful property of the canvas context, and there's a measure text method of this context that I'll use, which is dependent on this current state, like how large that font size is, and what it also depends on the font family as well. So this is what I'm going to do. So I'm gonna do the easy case first. So the layout is, what is the job of the layout? Well, the job of the layout is given a box, and I'm gonna walk the tree of the box because the box could contain nested children within them. I'm gonna walk the tree of this box, and I need to calculate a bounding box for the box. Okay, for a box I need a bounding box, and one way I could do it is to like have the box optionally have a bounding box. Maybe I call it, yeah, optionally have a bounding box, and then as it calculates it, it'll sort of stick it in here, just set the property of the bounding box property of the text box. But I feel like that's not clean because it mutates the object that is passed in. So instead of doing that, although I mean, I don't know, I'm still debating it. If you want to argue with me one way or another about this, feel free to leave me a comment. But I feel it's cleaner to, instead of just adding an additional property to the box type, I create a mapping between the box and the bounding box. And you might think, well, now we need IDs. Well, actually we don't, because every we can use the MDN map construct. So if you look at the map library, which is a new-ish API that's available in JavaScript, you can actually use objects as keys. A map object iterates. The map object holds key value pairs and remembers the original insertion order. Any value, both objects and primitives, may be used as either a key or a value. So one key thing that's different about map versus using objects as dictionaries is that a map can use objects as the key, and that's what I'm gonna use. I'm gonna map a box to a bounding box. Let me just try that. So which means my layout is actually gonna return a map that takes a box to a bounding box. And again, a box is something what I'm defining here. A box is either a text box that contains some text, or a container box which contains more boxes within it in a direction. And a bounding box is like, where should it be on the screen? It has a coordinate, top and left, and it has a width and height. So for each of these sort of text boxes or container boxes, we need to figure out its actual dimensions within this 2D coordinate that is the canvas. And this layout is supposed to figure that out for us for a box and any nested box within it. I'm going to do the simplest case first, which is if the box is a text box. Whenever you're doing complex algorithms, you should always start with the easy cases because you are having to keep so many things in your head that doing the easy cases first will take a load off of your mind. So I'm gonna do that. If the box type is text, it is a text box. How do you know the bounding box? Oh, something else that I remember. After this exercise last week, and when I paused my work on it, one realization I had was that I should pass in as another one of the layout's parameters. I should pass in the offset, which is like a top and left offset. Okay. Also, and I'll explain why, but I'm gonna do it right now. I'm gonna call this guy a point, whereas a point is a top and a left offset. That's what maybe I should call it X and Y, but I feel like I'm using different term. Maybe I should just call this X and Y actually. Yeah. So a point is an X and Y. Sure. So I should also pass in an offset here, which I'm calling a point right now. And maybe that'll become clear, but if it's not, then I'll maybe try to explain it further once we get a little further along. Okay, so if a box is a text, then we need to figure out the dimensions of this text. I know the height already because the height is going to be governed by the font size, which is actually not here. So perhaps I do need to pass that in after all. Okay, we'll pass in the font size. The font size is currently encoded in this string here, but we'll extract it out here. 25, and that will come in handy just a little bit later when we actually call this layout function. We'll pass in this font size. Okay, so yes, font size is another parameter that's needed because we're gonna use it right now. I'm gonna ask the canvas context to measure the text within this text box for me, and in return it'll return me a thing that has a width on it. It'll return me like a metric object or some text metrics, which if you look into it, you'll see that it has a width. That's going to be the width of our bounding box, of this bounding box. And then what's the height? Well, the height is actually just going to be the font size. And then what is going to be the X and the Y? Oh, that's going to, we're just going to use the offset that gets passed in. So the bounding box for the text box shall be the width, the height, and whatever is on the offset that got passed in. So now we have our bounding box, and we are gonna make a new map that contains this guy, and I think we can do it like this. Although I'm not 100% sure. Actually, let me Google this up. I want to make like an inline one-liner that creates a new map and just has this one entry in it. How do I do that? I make a key value array like this. Okay, this is what I thought. So I need to make a key value array, which looks like this. In my case, I'm gonna only have one key and one value, not two, which is why I have this double nested brackets here. And my key is gonna be my box, this guy, okay? My value is gonna be my B box, my bounding box. So my this box is the key and this is the value. So I'm generating a map and I'm returning it in the case of when the box is the text, okay? Else, I want to test this code in small increments, so I'm not gonna implement the else for now. So I'm gonna throw a new error, say not implemented for now, so that I can already write code that tests this layout function, but it can only work for a box that happens to be a text box. That's the limitation there. I changed the name of this guy. Top is now Y and left is now X. I'll switch the order. Okay. Okay. X, Y. Alright, let me see if this still compiles and runs. It appears to. And then I'm now gonna try to call this layout function. And it wants a box. We don't have a box yet. Alright, let's have a box. My box is gonna be of type text, and its text is gonna be hello. So that's my box. And that's what I'm giving to my layout function. And for the offset, I'm gonna use actually I'm gonna use 100 and y100 because I've drawn this box here, this bounding box. I want the text to go inside of it. Okay. What other parameter does it want? I forgot. It wants a font size and the context. So font size, I already have that. And the context, I have that. Okay. So this is probably okay. It wants me to make it very clear that this type is box. Okay, so I did that. Then the output of layout should be a map. Okay. Okay, so we'll print out what the map is. We'll just console.log it. I'll say the result is this map. And check the stream quality just in case. It still says excellent condition, good. That's what I want. I was worried that the streaming condition would be bad, in which case I would just switch back to recording. Okay, so this is the result, and we have a map, and the key is the box, which is this text box value, and the value is a bounding box. It's a location within the canvas, and it's a location and a dimension. So we can actually like stroke correct on the resulting box actually and see what where the box is. Let's go ahead and do that. So I wanna, and perhaps we extract this function here. Yeah, let me do that. I'll make a function called stroke box stroke b box b box bounding box given a context object. So this is canvas rendering context 2D. Okay, and I think that does it, actually. I think that does it. So I can refactor this guy to just say struct the speed box, and this still does the same thing, or no? Struct rec, oh, because I forgot to pass in the context into it, obviously. Okay, now that works, but now I can do struct bbox on the result of looking up the map with our box, like that. Also, it needs a canvas context, obviously, and that's that hello box right there. Oh, I drew this fill text, which I'm gonna get rid of now because I think that confuses matters. Okay, so maybe it's more confusing now than before. I have a separate line of code that draws hello world, but my box only has the word hello in it. Okay, so anyway, so this layout works for just the text, but perhaps we should also, instead of rendering this text like this in a one-off way, perhaps we should also have a render method that takes a box and the map of bounding boxes and renders that, and it will draw the bounding boxes for debugging purposes because it helps us to look at the bounding boxes. Yeah, let's go ahead and do that. So in addition to the layout, we also want a render function. And this is actually an interesting pattern. This two pass architecture, where you first one pass to figure out the layout and then second pass to actually render the stuff. That architecture I've done a couple of different things. Well, or I've done a similar kind of thing where I'm trying to implement a UI framework in the past, and I've come back to this sort of situation, this same architecture multiple times, and I see this architecture multiple times in other frameworks that are out in the wild as well. And when I see recurring patterns like that, that gives me more confidence that I'm going on probably the right path, or at least a perhaps well visited path. Okay, so I'm gonna render a box. Do I need an offset? I think I want to render a box. No, I need a map of the bounding boxes. So I'll call this bbox map. Bbox map. That's an interesting name. Which is a map that takes boxes to bounding boxes. I still need the context. Although in this case, I think I can get away with not having the font size because I'm just gonna assume that the canvas context knows what the font size is, and that's good enough for me. It's gonna return void, this one, because it's not actually gonna return you anything. Its job is to actually render the thing on the canvas. I misspelled this. This is canvas rendering context 2D. Okay. So how do you render this guy? Well, again, I'm going to cheat and only implement it for the text boxes for the time being. If it's not a text box, I'm gonna say not implemented. Okay, how am I going to do that? I'm saying design a box based layout framework. Maybe I should say implement because I'm getting really low level and nitty gritty here, and I'm actually making code that works for the current condition of working. Okay, so how are we gonna render? So if it's a text box, I think all we have to do is look myself up in this map to find my bounding box. Excuse my daughter. If you see a girl babbling, that is my daughter Emma. Okay, so given this bounding box, and actually we're not gonna measure it to figure out how wide it should be anymore in the render pass, because we don't need to tell when we fill text, when we say canvas.fill text. I mean, max width is a parameter, but we don't need that because the actual width of the text is just determined by the font size, which the canvas context already remembers what that is when we set it, and we're saying sort of the precondition of the render method is you set the font property on the canvas context. That's a precondition. I just made it up. I say it's a precondition, and now it is. Okay, so now, the only thing we need from the bounding box is the x and y coordinates, because that's where we're rendering the text. So now we should be able to say render this box, not man, but program entity. Okay, so I'm gonna render the box with this bounding box map, which we have calculated given the layout, and the canvas context as well. So now even if we take away this fill text line, I feel confident that it should still draw the text. And there it is, but without this render, I believe, then we would not get the text. Okay, right, so the render is the thing that's giving us the text. But I want to go one step further and say this even stroking of the box is done by the render. Let's do that. So in addition to filling the text, we're also just gonna stroke the box, and the stroke box wants a B box, bounding box, and we already got it right here for it, so just plug that in, and now we can render text boxes. Okay, we can first lay out a text box, and there we can first lay out the text box, and then right after you lay it out, we can render it. And I guess the result of the layout we can print it out. So I'll call this bbox map, maybe, to make it a little bit more precise. And if I wanted to debug later, I want to look at what's in the bbox map, I can open up this drill down, this map object. I don't know if you would call it an object. I know in reality anything in JavaScript is probably an object, but yeah, open up this map and look at the values there if I wanted to debug it. Okay, so now the next thing is I want to make this work for containers. as well. So I need to implement this guy. Start, and with containers there's vertical direction and horizontal direction. Let's just do one of those to start with. Okay. So I'm gonna say else if, actually I'm gonna leave this else clause alone and add another else if. So else if box type is a container, I'm gonna say if the box direction is vertical, then do something else. I'm gonna throw a new error not implemented. Okay. Okay, what are we gonna do if we're laying boxes out vertically? So this case would look like this. Instead of the top level box being a text box, the top level box will actually be a container box. It will have a direction of vertical, and then I'll have children, which is an array, and then within the array we'll have a number of text boxes. Actually, they can also be excuse me. These boxes can also be containers as well. But we'll deal with the simple case first, which is where the inside is also a text box. Okay. So we'll first work on the layout, and then we'll need to implement render as well for containers. Okay, so we're here just for the case where the box direction is vertical. How are we gonna deal with that? Well, let's loop through the children. So for child of box.children, like that. Because if you're a container, you're gonna have children. Sort of reminds me of boxcar children, which is cool. I like it when code has references to literary works. Okay, so for each boxcar children, for each child, we're gonna ask the layout function to lay it out. We're gonna pass in an offset. This is where the offset makes a difference here. Okay, so let's try this. We're gonna call the layout, so each, because every time you call layout, let me just write out the code to call layout first. The child is a box in of itself, so that's the first parameter. Offset, that's a great question. We'll need to make adjustments as to what offset we pass, but for now we'll just pass our own offset, the same offset that was given to the parent container. And then font size doesn't really change, so just pass it right through, and then the context. So what you get as a result is the bounding box map that only contains the bounding box for the child, like that. And I guess what we want is to have a bounding box map that merges all the bounding box maps for your children, and then you have to add your own entry into it too. So how do you do that? How do you merge maps? I think what you do is, or how do you add more entries? You could do this guy where you spread the maps onto the array. That's one way. You can, I guess you can do a whole bunch of these set statements. That's another way. I don't know. this is one way, I guess. Maybe I can have, maybe what I do is I make an array, and then each time we loop through, we do array that push, and then we do a spread to push multiple things, or I could do concat as well, or maybe I just do the array spread operator thing, and then at the very end I do a new map with that array. Okay, so I'll make an entries array like this, and then each time I'll say entries that push, I'll spread this B box map onto it, and at the end I just return a new map of these entries, but not before adding my own entry, because at the end I actually want to figure out the bounding box for the container, and the bounding box for the container actually depends on the bounding boxes for each of its children, because if you were to lay out, like, you have a hello, and hello says I need to be this tall and this wide, and then you lay out world below it. Now you actually want to say that, well, my bounding box is this one, which contains both of them. Okay, so, and also for the second child, this world, we actually need to tell it that it should start laying itself out at this offset, this dot here, and that is the offset parameter. So which depends on the height of the previous child, actually. See, the height of hello determines where the offset of the next child should go. So this guy actually needs to be modified too. I'm gonna need a running y offset, which starts at 0, but then each time it needs to be added, the height of the next child needs to be added to that. Okay, so but the offset would need to be the for the x direction is just 0, but for the y direction it should be y offset, and that's the offset that needs to be given to this child layout call. These pop-ups are kind of getting a little distracting. Okay, and this y offset now, I misspelled offset. These offsets now need to be added too. Based on the bounding box of the child, which can be gotten by looking up the map, looking at the B-box map with that child again after we got the B-box back, and then it needs to be what the not width, but what the height. Whatever the previous child's height was, we're adding it to the offset, so that the offset that's passed in to the calculation for the next child is starting at that point. Okay, and yeah, and then I think at the very end we're gonna need to add a new entry for ourselves. Oh, I also need a max width, or I should say the width of the whole container should be the maximum width of all its children, right? Whoever is the child that has the longest width, the container should have that width. So I'm gonna make a my width variable which starts at 0, but I'm gonna have to reuse this chunk, so I'm gonna extract it as a const. I'll call it child b box. Okay, so if the child B box's width is greater than my width, then I'll set my width to that. Okay, that works. So at the end, the width of the container should be equal to the Y offset, because we've been adding the height of each child to the Y offset. So the final height should be, I'm gonna add one, so I'll make a container B box, which should be a bounding box. So the container B box, its offset should be whatever is the passed in offset. That actually doesn't matter, but the width, let's do the height first. The height should be the Y offset, and the width should be my width, and that's my bounding box, and I need to add that to the entries. So I'll do push a key value pair, which is gonna be box, which I think is, yeah, that's me. I'm the container box, and then my bounding box is container B box. Now we grab with all our key value pair entries in here, and finally we create another map to be returned, which will contain the entries for me and all my children, if everything worked correctly, which I'm not sure it does. But the render method has not been implemented, because we only implemented support for containers in the layout method, but not in the render method. So the render method says, it throws this error, says not implemented here, but that's okay, because the code we wrote it's responsible for making this map, and let's see if it's correct here. So it's saying there's two entries for text boxes, hello and world. That is right, and both of them have the same width and height, which makes sense because they both have 5 letters, I guess. And then there's a container box, which has a which also has a bounding box, and it is set to xy and then height of 50, which seems right because that's the sum of the two 25s, and then a width of 62.5, which is, well, both of the texts were the same width, so it just supposed to take the largest of the two. So it seems to have done that. The XY value, was that correct? I would say it's not correct for the text here, because these should be offset starting from 100, 100. So I think this is where we went wrong. This X should be offset X. It should inherit, in a sense, the X and Y offset of the container when we pass it in, and then is to the Y offset, it should initialize at offset.y instead of 0. So let's try that again, and now it'll probably look, yeah, now it looks better. So the hello is gonna get rendered at 100, 100, and then the world is gonna get rendered at 100, 125, which may be like around here. Now we just have to implement this render function to make it actually show up on the page. So let's do that. We'll do this same if statement here. And again, for the horizontal direction case, for now we're gonna throw not implemented. Computer seems a little slow again. Whoa, what just happened? I totally messed up. Undo. Oops, redo. Okay, I think this is good. Let me check the stream quality. It still says excellent connection, so that's great. I think it's just maybe my text editor or the TypeScript compilation being a little slow. Okay, so I actually want that code to be here. I'm just gonna type it out because my text editor is getting confused. So if, else if, some condition. And that condition is if this is a container, then we're gonna do another if the direction is vertical, else it's gonna be horizontal, but for now I'm gonna throw not implemented again. Okay, so if it's vertical, then we're gonna actually it doesn't even matter whether it's vertical or horizontal now that I think about it, because the job of laying out has been done, and the job of laying out gives us these bounding boxes, which if we just use them, it will tell us how to render the things, so we don't even need to care whether it's vertical or horizontal at this point. So all we need to do is actually just loop through the children. So for let child of box children, for each of your boxcar children, you're gonna render them. Which is child, and you just pass the bounding box map, which there is only one. You probably also want to do the stroke B box on yourself, which is the same as the above. Okay, let's just see if that works. Interesting. I feel like the parent box is bigger than it needs to be. So let me check that. It says height is 150. But it actually doesn't need to be 150. The height should be 50. So I think I know what happened. Because I set the offset, the Y offset to that, which it would be 100. But that's actually not the how should I explain this? So this is 100 100, and this guy would be offset Y. So offset Y, that starts off at 100, and then each time we render this guy, we're saying, hey, add this, which I think was 25, and this was 25 as well. So it's at add 25 to this 100. You just go in here, and now it's plus 25, and now it's 125, and then we're gonna add this 25 over here plus 25 again, and now it's 150. And then we end up with this 150, which is where this is relative to the top of the canvas, but it should not be the height of this box. The height of this box should be just 25 plus 25, which should be 50. So what I'm gonna do is, instead of starting this at Y, I'm still gonna start this at 0, but I'm gonna rename this to call it the height offset. and put the height offset in here. Oh wait, no, I'm not gonna do that. There's a drawback to doing it that way. I'm not gonna do it that way. I can just make another variable called my height, start it at 0, and then in addition to adding this height to the y offset, I'll also add it to my height. Even though it requires an extra variable, but I think that gives us the benefit of more easily understood code here. So this height uses my height but not the y offset. So let's see if that fixes the problem, and it does. So now I have hello world, and the box of the container is also correct. Excuse Linus. There it is. Okay. So yeah, so now I have this render function and the layout function working, at least for the vertical case. Well, I'll throw a couple more cases to it. Add another line of text, and yeah, so you can see that with varying with please be quiet. I'm recording, you know. This text box, the parent container that has to surround all three of these texts, it has to be wide enough to accommodate all of them. So it takes the maximum of their widths, and that's the parent container's width. Okay. Now we have to see if it works recursively. So like, what if one of my children is not a text, but it's actually another container, then what happens? Direction, and currently I can only do vertical. Okay, so I that should work just the same, even though I have nested it in another box. A grandchild. So yeah, so that still works. You can sort of see that the box is darker in the places where it got stroked more often. So like this line is darker than this line, for example. So that's how it's supposed to work, and that's fine. All right, let's do horizontal boxes now. Okay, so what if this was horizontal? Well, before I implement it, let me draw out what we should expect, right? So we should expect, oh, that would get kind of crazy, actually. So maybe I'm gonna write cat kid here instead, like have a shorter text. So if it were horizontal, we should actually see like cross this out here, or we should get hello world, and then whoops, cat kid. That's what we would get if horizontal worked. Okay, let's see if that's the case. The horizontal code is actually gonna look very similar, and also I don't actually have to change any code in the render method because this is independent of direction here, so that's great. But for the layout method, I need another block that looks mostly like this, except for the width and the height logic needs to be swapped. So I'm just gonna do that in a very quick and dirty way. Just copy this code and make another copy of it. I'll say else if box direction is horizontal, then that. But I'm not gonna now going to sort of change all the bits that need to be changed, which are this, instead of a y offset we have an x offset, which should initialize with x, and here I just switch the order of these things. So wait, whereas before it was y offset here, now it's x offset, and x offset, and then offset dot y here, and then here it should be x offset, and then this switches from a height to a width, and then this my width switches from a height to a width, and this also switched from a width to a height, switches to a height, width to a height. So this is my height, and this is height, and but this doesn't have to be changed because we have both height and width. I think that should work. Let's see. Yeah, that worked. Hello world, and then CAD-Kit is laid out horizontally, whereas hello world is laid out vertically. Now we can create structures that are, let's see, just based on changing this sort of tree, this nested tree of boxes, we can change the layout of these text. Oh, we probably need like padding at some point, but yeah, but that should be relatively straightforward to implement. Let me think. So I'm going to I'm gonna do a horizontal at the top level, and then 2 sub containers which are vertical. And then within each one I might have like the first one, I think let's do this like code numbering, so like 1, 2, these are like line numbers, let's say. So 1, 2, 3, 4, 5, 6, 7, 8, and then but then this one is this I also have vertical. This one is actually lines of code here, so this one might be, I don't know, def main the last line might be like the closing bracket, and then this one might be print fib of 7 or something like that. So let's see if that renders okay. Yeah, that nice. So that renders okay. That looks like code to me. I like it. In terms of padding, we might add the ability to specify padding in the same way as CSS, the CSS box model, and perhaps you can specify padding in all 4 directions, either in terms of pixel value or in terms of M value, which, let me Google M font size. Is M like the width of a character, or is it the height of a character? Because what we have, when we have font size, that's when I have font size that is the height of a character. An M is equal to the current font size. Okay, so maybe the font size is just M is probably just same as font size then. So that's cool. We can implement that. I don't think that would be too difficult. But I'm gonna stop this stream because I think that's a pretty good chunk to stop at. But before I stop this stream, I'll just lay out sort of the next steps in this work. So next steps would be add support for padding, and maybe add support for enable versus disable borders. So currently I always draw the borders for debugging reasons, but later on we may not want that. But really the next more interesting thing that I want to do is like why did I decide to build this thing in the first place? I guess I need to figure that out. Oh, it is for the case where this fib, which is a call expression, so that this fib should actually be modeled as another container. So this is how I want to represent this. I want another nested container here for line 2. And its direction is gonna be horizontal, and it's gonna have children. Okay, but its children, I'm gonna split up this text into 3 parts. The first part is the part before the fib call. The second part is just the fib call, and then the third part is the part after the fib call, which is just a parenthesis. So if we did that, yeah, we see this box around this fib call. Actually, I have an extra parenthesis. Let me get rid of that. So we have this box around this fib call, and I want to make it so that the rendering code, when you zoom in to this fib call, like that. Right now it's not using my zoom mechanism. This is using the native browser zoom mechanism, which is why this is pixelated. But when you zoom in deep enough to the fib call, I want it to actually render the details about the execution of the fib function, and lay out the code within the fib function inside that box. Okay, that's why I did this in the first place, and I think what we have here is going to enable us to do that, and yeah, hopefully that will be fruitful. So I guess the next step is make the function call zoom in possible. So hopefully that's coming in the future. Yeah, that's all I got. I'm gonna stop the stream now. Thanks for watching if you are, and hope to see you soon.